All right, so let's talk about how you build a network. Okay, when you're putting a network together, you're going to use certain devices to do that with, and you may have heard of these things before. So let's talk about what they are. Now, a hub is a data splitter for networks, and the problem with this is that it multiplies the traffic. Remember, when we build a network, we want to make sure to minimize the traffic to make the most effective use of our bandwidth. When you build your roads, you want to try to keep as much traffic off of it so that the fire trucks and the police cars can get through, right? And this works against that, because what happens with the hub is that it's a data splitter. If you have your computer connected to it and you send a message, it's going to duplicate that message at every port, and it's going to broadcast it to every device on the network. So these are not very good for our purposes. So we used to use hubs a lot, like in the 80s and the 90s. We no longer do. They're pretty much obsolete now. I mean, you still use other kinds of hubs, like you can buy a USB hub to connect a bunch of different devices to your computer. But as far as Ethernet hubs go, those are pretty much out. Instead, we'll use a switch. Now, a bridge extends the range of a network. A bridge has one input and one output. And if you can have two separate networks, and you can bridge them together, or you can extend the range of a network. So for example, if I bought two routers and I put one in bridging mode, then the second router will take that information and rebroadcast it, and it'll extend the range another 150 or 300 feet. The problem with a bridge is that it adds latency to the network, and so it doesn't make the most effective use of our bandwidth. Now, a switch comes out of the telephone industry. In the old days, when when phones were just being developed, there was a switchboard operator that would take an incoming call and physically patch a phone to another phone. And so now this does exactly the same thing, but of course it does electronically. It's much faster and much more efficient. So the way a switch works is that, as you saw earlier today, just like the router, when you turn on your switch and you plug in a device, the switch performs a handshake with the device. And it says, "Who are you?" And the device will tell it, and the switch will go, "Oh, great, what is your MAC address?" And it records the MAC address. Now, if the switch is running DHCP, it will assign that device an IP address. And now it knows its name, its MAC address, and its IP address, and it starts building a switching table. And the next device will do the same thing, and the next and the next, and now it's got a list of all the devices, so that when a message comes in to the switch, it looks at the header, and it says, what is the destination IP? Where is this message supposed to go? And then it will then look in its routing table to see if there's a connected device that matches the IP address. If it does, then it outputs it to that port to send that message through. Now, there's different types of switches. There are layer 2 switches and layer 3. That comes from that OSI model. Remember, layer 2 is their physical layer, the data link layer, and that the data link layer, layer 2, works on the MAC address, the media access code address. That means that all of its operations are based on the MAC address rather than the IP address. A layer 3 switch is just the opposite. A layer 3 switch works on the IP address, and there's a difference between those two types of switches, and sometimes there are some things that you need to know. Like, for example, if you are using streaming ACN to minimize the traffic on the network uses multicast. It has multicast traffic. Some layer 2 switches convert multicast traffic to broadcast. And so therefore, if you think you're minimizing the data on the network, making the most efficient use of your bandwidth, if you have some layer 2 switches will work against you that way and just broadcast everything. Now, as we were talking about earlier today, there's a difference between a managed and an unmanaged switch. A managed switch, I'm guessing that this Netgear switch is a managed switch. This is like a 48-way managed switch, and it comes with the manual that's thicker than the switch itself. I'm exaggerating a bit, but the point is that there's a lot of features in here and a lot of configuration. And sometimes it can be difficult just to get it to work with our kind of traffic. And you may not want a firewall for a private network. You may not want antivirus protection for a private network. You may not want certain things. On the other hand, there are some nice things that managed switches do. So, for example, you can do what's called trunking. And that would be if you take two cables, you can kind of bind them together to act as one, and that gives you twice as much bandwidth. So if you have a 100 megabit per second port and another 100 megabit per second port, or a gigabit and a gigabit, now you have a 2 gigabit path for data to get around the network. If you can configure this for trunking, that kind of stuff. They also have things like flow control. Flow control is where if the console is sending data at a rate faster than the device can receive it, then the data spills out, it overflows. And so it can't keep up, so it overflows. Well, if you have a switch that has flow control, it will sense whether or not the receiver is keeping up with the data, and it'll pace it accordingly. So it will buffer the data and dole it out at the right speed so that the receiving devices can deal with it. Those kinds of things. Now, there are also managed switches that are made specifically for our industry. There are a number of different managed switches. And the nice thing about them is because they're made for our industry, they're tailored to our needs. Like, for example, you saw that when I wanted to configure this router, and the same with my switch. If I want to configure the switch, what I have to do is I have to connect it to my laptop. Now, these days, Macs don't have an Ethernet port, which means now you have to have a USB adapter to go to Ethernet, and you have to have an Ethernet cable, and you plug it in, and then just like we configured the router, you would open up a browser page, and you type in the IP address for the router, or for the switch, and you open up a configuration page, and then you can turn the features on and off, right? So, that's not necessarily that quick or easy to do. So if you have a managed switch, sometimes they have things like encoders on the front with the menu, so you can do all of the configuration at the switch instead of having to bring your laptop and connect it. I don't like bringing my laptop to gigs. Why? Because it's going to get lost, broken, stolen, or a forklift's going to run over it, right? So I don't mind carrying my phone in my pocket. I don't go anywhere without it, but I'm not going to bring my laptop. And sometimes you need, for just a commercial switch, you need those kinds of tools. So that's the advantage of having these. They also have certain features built into them that allow you to do certain things, So, for example, we said earlier that if, say for example, you're setting up a show and you have a switch at the console and you have a switch on stage or in dimmer beach or back of house, and you've got 200 lights. And as you're setting up your system, you have your switch at front of house, you connect it to the console, and then you take an Ethernet cable and you plug it into the switch, and you're running it back to your fixtures. And as you're laying out your cable, you're thinking to yourself, if this cable breaks, if it accidentally becomes disconnected, if a forklift runs over it and cuts it, I've lost control of my entire rig. And it's not a very comforting feeling, right? But if you look at your switch, you'll notice, oh look, there's a whole bunch of empty ports here. Why don't I run a second cable to the lighting system. And that way, if the first one breaks or gets disconnected, the other one will be right there. And the problem with that is that if you run 2 cables, then the data is going to go through the first cable to the second switch. The second switch is going to get the data and send it back to the first switch via the second cable, and back and forth, and it's going to keep going around and around and around. Meanwhile, the console will be generating new data, and the data is going to add up, and you're going to flood the network with traffic, and it's going to crash the network. So it doesn't work to have redundant links or to make a loop and close the loop unless you have a particular type of switch. And most of the switches in our industry do. They have redundancy, built-in redundancy, or what they call ring protection, or Ethernet automatic switching, I think it's called. So this is a little video right here, I think it is, that explains one particular type of switch and its redundancy protection. Yeah, Raphael?
Going back to the layer 2 and layer 3 switches, what does the industry use more? I'm assuming layer 3?
So Raphael's question is, we have layer 2 switches, we have layer 3 switches. What is more common in the industry? In my experience, most of the switches I see are layer 3 switches. Okay? All right, so here's a little video about redundancy and ring protection.
Welcome lighting friends, Robert from Pathway Connectivity Solutions, and today we're going to talk about the VIA switch, in particular the VIA 12, and demonstrate our ring protection system, which is an implementation of EAPS, or Ethernet Automatic Protection System. And this is very important when you have a large installation, that you don't want, if everything is going down one piece of Cat5 and there's possibility of a failure, you want multiple paths to go from front of house to the stage to make sure that the show goes on. So if you build a topology with a ring using the VIA 12, what you have on the front is lots of places to plug in consoles or pathport nodes or any other devices, and they go in typically to the front of your VIA 12. But on the back, you have the option of gigabit copper or fiber. And typically with large installations, you might use a fiber backbone because it can go a lot further than 100 meters, or copper, doesn't matter. But the ring will be built out of these dual ports on the back. And what happens is data will go out in 2 directions, to the clockwise around the ring and counterclockwise around the ring using these ports on the back. And when there is a failure in the ring, you will not see a glitch in the DMX data stream at all, because our ring can heal itself in less than 50 milliseconds, and quite often less than 20, which is sub DMX refresh rates. So to demonstrate, I've got a table here that has 4 VIA switches hooked up in a ring. I have data leaving my Cognito console, which is being powered over Ethernet by this VIA switch. Data goes off in 2 directions to 2 more switches that might be in the building, then off to another one, which does distribution into a C-series node, which becomes DMX and goes to my Verilight. So for this demonstration, I'm just going to put the Verilight on the wall, and it's going to continually do a circle. And I am going to interrupt parts of the ring at different times by unplugging, or whatever, the DMX. So clearly I've unplugged both sides of the ring here, so we have an air gap between front of house and stage. Our data is not getting there. But when I plug things back in, it will pick up and keep doing its circle. So watching that light going around in a circle like that, what I'm going to do is I'm going to come over somewhere between the stage and front of house, and I am going to cause damage to the ring. So now, data, because of this master switch, has seen that there's been a break in the ring. It starts sending the data to the stage in this situation counterclockwise. So it's now leaving here, going around that way, coming out and making stage. I'm now going to heel the ring. I'm going to plug it back in this way, and there's a message on here saying that there was an interruption in the ring and it has been healed. You don't need to see that. All you see is that the light is doing what it's supposed to. Now I could come over to this guy here and I can unplug it. And again, the light, the data is now going clockwise around the ring. Got to stage with absolutely no interruption. If I heal the ring again, this time let's do something a little bit more catastrophic. What I can do is I can remove the switch completely. In this case, by removing its power. So this side of the ring is dead. It's healed, it's going the other way around the ring. I can now plug this guy back in. It'll boot up within a couple seconds. The ring will be re-healed. We'll start sending the data probably clockwise, counterclockwise. I've lost track at this point. But then you can have even more catastrophic failure. You could take one of the lines like this, and a forklift drives over it, cuts it like that, and the data is still going around the ring. And we have a light doing its thing on the stage. So that is our implementation of the ring protection system that's available on the VIA switches. Until next time, thanks for joining me.
So, you know, a lot of industry-specific switches have features like that. Now, a router, we use switches to create networks. We use routers to connect networks. So, for example, you probably have a router at home, and it's connected to probably your cable modem. So, if you go to the your internet service provider and you subscribe to internet services, then they will give you a cable modem. Now, the cable modem, the internet service provider owns a list of IP addresses, and they will let you borrow one if you pay them money. They'll rent one to you, right? And so they assign it to your cable modem. When you come home and plug it in and plug in your router, now you have an interface to the outside world. So that's the purpose of the router, is to connect your private network inside of your house to the outside network to the rest of the world. And there's a firewall in between. The firewall is there to protect you against all the guys wearing black hats. And I don't mean Daniel, but the guys that want to hack into your system. And so what happens is that when you are on the network, on your private side, when you send out an email to New York City, then that message goes across the firewall, it goes out on the internet, and when it comes back, it's using the IP address from the internet, the internet IP address, but it hops the firewall and then it changes the IP address to your local network IP address. So you have two different IP addresses. One is for your private network, one is for connecting to the internet, and it's the router that connects the two. So just like a switch does, you saw where my router will, when you log on to it, does a handshake, gets the MAC address, assigns it an IP address, because my router's running DHCP if I don't turn it off. And so it knows your MAC address, your IP address, and the same with every other device that's connected to the network. Now, if I do connect my router to the outside world or to another network, it becomes an access point, so it's a wireless access point. Now, a gateway is a protocol converter. We have lots of gateways in our industry because there's lots of protocols. So if you want to convert from ArtNet to DMX, or from streaming ACN to DMX or back, then you use a gateway. There are external gateways, and typically they're called nodes. So if you hear 2-port node, 4-port node, 8-port node, that's really a gateway. In the rest of the world, like in the computer world, anything that's connected to a network is called a node. But in the entertainment industry, for some reason, we call gateways nodes. And I think that's because the first company that made a gateway called it a node, and so it just kind of stuck. And so now when we're talking about nodes in our industry, really what we mean is gateway. There are a couple of companies that actually call them gateways, but a lot of companies call them nodes. But it's the same thing in our industry. And now, as we talked about, some fixtures are starting to have gateways built into the fixtures. So again, if you see an Ethernet port on a fixture, if there's only one Ethernet port, that means it has a built-in gateway that converts from ArtNet or streaming ACN to DMX. And there are advantages and disadvantages to each. Now, power over Ethernet is where two of the pins on your Ethernet cable have 48 volts in order to power handheld devices or wall stations. It's a nice, convenient feature in certain applications. But in order to use power over Ethernet, you need a switch that has a PoE power supply. And they make switches where you can pay extra to have a second power supply to put those 48 volts on two of the pins of your Ethernet cable. And they make different size power supplies. There are some that are 90 watts, some that are 120 watts, some that are 150 watts, depending on your application. Now, Ethernet technically is called TCP/IP, and TCP/IP stands for Transmission Control Protocol / Internet Protocol. And it is a suite of 4 different layers of software that work together to get data across the network. The whole idea is that you can use any type of device to send data over an Ethernet network. It doesn't care what kind of device you're using. You can have a Windows operating system, a Mac, you can have Unix. It doesn't care. It just gets the data across the network. So it works with all different types of devices. So in TCP/IP, there's the application layer, which is kind of like the operating system of the network. There's the transport layer, which is responsible for getting the data across the network. The internet layer is responsible for delivering it to the proper address, the IP address. And the network access layer is kind of like the traffic cop that resolves data collisions. Because when you have a whole bunch of computers or devices on the same network sending data at the same time, you do have data collisions. But this is how it resolves those, and it tries to prevent them at the same time. Yeah, Zach?
Does that mean on a network switch? Because I have this on mine, but I don't know if I'm getting lucky. I have a couple computers, one computer that's connected to the internet, and another computer that I use to control the fixtures that I'm testing. They're all going on one network switch. And so with this network switch, I have a main network switch and one computer going to the internet, and then another computer going to the network switch with a E-node that's also going to the network switch. But this computer and the E-node are both on the same IP. Am I just getting lucky, or is that completely allowed?
No, it's allowed. In fact, what you built is similar to a virtual LAN. A LAN is a local area network. And a lot of switches, like this Cisco switch, a managed switch allows you to separate traffic based on traffic type. So you can actually go in and build a virtual wall between this traffic and that traffic. And if you set it up properly, it works just fine. Now, if in your case, if you just did it remember, for any two devices on the same network to communicate with each other, the IP address has to start with the same number. Like this morning, we had 192.168.0. So for all of us to communicate, all of our devices had to have an IP address that starts with 192.168.0. If you change your IP address to 192.168.5, you would not be able to send a message to anybody else in the group that had 192.168.0. So that's one way of separating traffic. Then another way is to configure, to purposely put in a virtual wall between one type of traffic and another type of traffic. That's called a virtual LAN or a VLAN. So if you go into a commercial switch, you'll find a VLAN setting. And if it's configured properly, then it's as good as having two separate switches or two separate routers and two separate networks. You know, last October I was down in Buenos Aires and I was doing some work at a television studio down there. And they had a grandma console that was controlling lights in the studio, but it was using the company-wide network. And when I first got there, and I learned how they had it configured, I was a bit concerned that maybe the email traffic and all the other traffic on the network might be interfering with the control of the lighting and might have been causing some of the issues that they were seeing. Now, a friend of mine used to work at High-End Systems, and he left and went to work for Cisco, and he's an IT expert. I called him up and talked to him about it, and he said, no, it's fine. As long as it's configured properly, it's as good as having two separate networks. So you can do that, absolutely. You know, and one of the applications, for example, if you go into an arena to do a show, and you only have one physical network, what you can do is you can tell all the lighting people, your IP address is going to be 192.168.1. something, and then you can tell the audio people 192.168.2, and video is 192.168.3, and production might be 192.168.4. But in order for that to work properly, the subnet mask has to be configured properly as well. So we will talk about subnet masks. Well, it's coming right up, actually. Okay, does that, yeah.
So for our net, we have the 2 dot and the 10 dot. So say if I configure my IP address of my laptop to 100 dot, and I can configure a node to 100 dot as well, will they still talk the same?
Yes.
They will?
Yeah. So, and we'll get to that in a moment. The whole issue with ArtNet, either using a 2 dot or 10 dot, that's an interesting topic. We'll talk more about that in just a moment. It's coming right up, okay? Any other questions or comments? Okay, great. Let's see, what time did we start back at? Oh, yeah. You know what? Right now is a great time. Let's go ahead and take a 10-minute break, and then we'll resume.